All right, problem 6.30, it says find the equivalent capacitance with respect to terminals A, B, the circuit shown. So ideally we want to start from right to left since our terminals A, B are on the left side. So capacitors work sort of the opposite way of how resistors. Whatever capacitor is in series, we take it as if a resistor was in parallel. And if we see capacitors in parallel, we take the equivalent of them as if they were in series for resistors. So I'm gonna make this my C equivalent 1, right? I'm not even gonna mention the fact that it's nanofarads. I'm just gonna say 1/48 because all of them are nanofarads. And the voltage across these don't really matter. We're looking for the equivalent capacitance, right? So we can just ignore the voltage across each capacitor since we're not really focused on that. So first equivalent capacitance is 16. Okay, and then I'm going to move on to here. So these are in parallel, so we can say equivalent to is 16 plus 4, which is 20 nanofarad. Right, so we have an equivalent here, and then once again, we have our series again, so C equivalent 3, right? 1 over C equivalent 3 is 1 over 20 plus 1 over 30, which is C equivalent 3 is 12 nanofarad, right? So now we have C equivalent 4. We have an equivalent capacitor here in parallel with this 8 nanofarad capacitor. So 12 plus 8, 20, and then for our last, I'm just going to do it with green again. C equivalent 5 would be all the equivalent here in series with this 20 nanofarad and this 10 nanofarad. So it'd be 1 over 20 plus 1 over 20 plus 1 over 10. C equivalent 5 would be 5 nanofarad. And this is our equivalent capacitance across the terminals A and B. So we would have 5 nanofarad. For our second part, right? Let's go ahead and do the same thing. So, let's do that. Okay, so you can start here. C equivalent 1, I'm going to call this 1 over 36 plus 1 over 18 plus 1 over 12. C equivalent 1 is 6 microfarad. Okay, so then we have, well, you want to do, you can actually start with this one. We take an equivalent and then take the next equivalent in series, right? And call, let me make some, yeah. Yeah, so C equivalent 2 is 25 plus 5 microfarad, 30 microfarad. So then I'm just going to draw an equivalent circuit here. 30 microfarad. 24 microfarad. Six. Okay. Let's make some more space. Okay. All right. So, oops. I call this C equivalent 3. 24 plus 6, 30 microfarad, right? So then this turns into this. And now we have these in series. So our equivalent capacitance look like this. And this is 10 microfarad. And yeah, I think that's the last part to this problem. Let me make sure. Yeah, there's only 2 problems.